So we're going to look at the example with the jelly beans again, where we have 1 blue, 2 purple, 3 green, and 4 red for a total of 10 jelly beans. And we just want to practice some basic probability here. To shorten the notation a little bit, for blue, I'm going to use capital B. For purple, I'll use capital P. For green, I'll use capital G. And for red, I'm going to use capital R. So we're going to draw 1 jelly bean from the set, and while we don't know which color we're grabbing, we can determine the probability for each color. So, with the first question, what is the probability of drawing a green jelly bean? Using our probability notation, we want to use P and then parentheses around a G to represent probability of green. And then we create our fraction. So in the numerator, we want the number of green jelly beans, which there are 3, out of our 10 total jelly beans. This will be 0.3. So there is a 30% chance of drawing a green jelly bean. For part B, what is the probability of drawing a purple jelly bean? So we're going to have P and then in parentheses, P for purple, so probability of purple. So in the numerator, number of purple jelly beans, which is 2, out of our 10 total jelly beans. So we'll have a 0.2. So for our sentence conclusion, there is a 20% chance of drawing a purple jelly bean. Then for part C, what is the probability of drawing a blue or red jelly bean? So with or, what we're saying is one or the other or both. So if we're looking for the probability, so P parentheses and then B or R for blue or red, in the numerator, we want to combine how many are blue, how many are red, and how many are both. So we have 1 blue jelly bean, and then to combine with the red jelly beans, we add. So we add it with the 4 red jelly beans. And then we would add on, like, which are both. However, we don't have any cases of drawing a jelly bean and it's blue and red at the same time. So we just have 1 plus 4. So you see this word or, it often brings through addition. And we often use an addition rule when we see that word or. So that's something we're going to practice later on. But for our numerator, you add the 2 out of the 10. So 5 out of 10, so 0.5. So there is a 50% chance of drawing a blue or red jelly bean. So with or, use addition, and we'll talk more about that rule in a future video. What is the probability of drawing a jelly bean that is purple and blue? So this word and is kind of exclusive. Here we're drawing a single jelly bean, so it's like we're looking at these 2 characteristics at the same time. So we want both qualities at the same time. So with that, if we're looking for this probability of purple and blue, then for our numerator, we want all of the jelly beans that are both purple and blue at the same time, which we don't actually have any jelly beans with that property. So with that, our numerator would be 0 out of 10. So there is a 0% chance of drawing a jelly bean that is purple and blue. So basically that scenario there is impossible. What is the probability of drawing a jelly bean that is not green? So we're looking for the probability of not green. If we build our fraction, it's like in the numerator, we want all of the scenarios that are not green. So it could be blue, or it could be purple, or it could be red. So we end up adding together those cases, 1 plus 2 plus 4 to make up our numerator out of 10, which is 0.7. So there is a 70% chance of drawing a jelly bean that is not green. Now that works great for this scenario since we have kind of limited outcomes, but imagine we had all different shades of jelly beans and we knew we had 3 green jelly beans and then thousands of other jelly beans of other colors. Then this numerator gets kind of tricky to calculate. What we're doing with this scenario of not one of the categories is we're just excluding one group. So this is called a complement rule. So with complements, it's where we're looking for the probability of not some event. And the idea is that that's the only event that we want to exclude. For our notation, we use our P in parentheses, so probability of, and then you write your event name, which for this formula we're using A, and you use this little, it's like an exponent of C, but really this is reading as probability of the complement of A. So for our example E, where I want probability of not green, I could have written that as probability of, so P parentheses, G, and then this kind of C in that exponent spot to say the complement of green, instead of writing out not green. And the calculation goes that we take 1 minus the probability of that event. So this 1 is representing 100%. So we're taking our whole sample space, and all we want to remove is the probability of that single event. So for this probability of the complement of green, it's the idea that we're taking all 100% of our jelly beans, and we want to take out those 3 jelly beans. So we want to take out that 3 out of 10 for those jelly beans. And when we calculate this, it'll give us that same 0.7 that we calculated above. It's just this complement rule is going to be better for when we have a lot more cases, much larger sample size, or sometimes maybe we only know the number of green, they don't tell us anything else, so you'll need to use this complement rule to calculate. So let's try that again, looking for what is the probability of drawing a jelly bean that's not purple. So we'd have probability of, so P parentheses, and then P with that little exponent of C. So probability of the complement of purple, you take 1 minus that probability of being a purple jelly bean. So we'd have 1 minus that 2 out of 10, which is 0.8. So there is an 80% chance of drawing a jelly bean that is not purple. So those are some basic probabilities right there.